What we're going to be doing today is looking at box plots or box and whisker diagrams. What these are a way of representing how spread out the data is. First one, we're given this question about tests of students in Maths Town School. So generally, to draw the box plot, what you need is the maximum and minimum values and then all the quartiles, so your median, your upper quartile and your lower quartile. So we're given all of those in this question here. I'm also given, which is very important, the axis label. You need to make sure you label your axes and have a scale when drawing your box plot. The way we do this, you draw two vertical lines at the maximum and minimum value. So the lowest mark was 18, so we're going up. So from 10 to 20 is 5 boxes, so every box is 2. So 18 will be about here. And then we're going all the way up to 86, which is about here. Now generally the quartile boxes will be a little bit longer than the max and minimums. As long as they're the same length or a little bit longer, that's fine. Just try not to make the quartile lines smaller. So the median's at 57. So we go 3.5 boxes. The low quartile is at 32. So 32 is over here. And then the upper quartile, we're actually not given the upper quartile, but we're given the interquartile range. So if you know the IQR is upper quartile take away lower quartile, the upper quartile should be the IQR plus the lower quartile. So in this case it's 38 plus 32, which is 70. So we're going to sketch that line at 70. And then we connect all of them. So generally the middle box needs to be the same size or a little bit bigger. And we've drawn our box plot there. Alright, let's see another question. So this time we're given the maximum, minimum, and we're given all 3 quartiles, so you don't need to work any of them out. We're given a scale, so once again, this time we're looking at time in minutes, and we're given the scale here. If not given scale, try and pick a scale where you can roughly, don't have to go between boxes when sketching all your values. So we're looking at our shortest time, which is 18. This time it's 1 box for every value. So 18 will be 3 across. So let's draw a small line there. And then the highest value is at 44. 1, 2, 3, 4. Next, the lower quartile is at 25. The median is at 29. Next, the lower quartile is at 25. The median is at 29. Alright, for this question we're looking at time in minutes. It took some girl to do a jigsaw puzzle. So you've already got a box plot diagram graph area here with the time as your scale. Our shortest time is 18 minutes. Now this time we're going 10 boxes for every 5. So every 2 boxes represents 1. So for 18 we have to go 6 boxes from the 15. Like that. And then we need to go 44. So 2 boxes from the last one. Next, we need to draw our low quartile, which is at 25. You want to make this a little bit bigger once again. Your median is at 29. And then your upper quartile is at 33. And then you just join everything up. Like that. Right, next. So this time we're given a second box plot and we need to compare them. When you compare them, you want to compare either the median or the interquartile range, or in most cases both of them. So the median here is about 25.5, and the median in the first box plot was 29. So this, once again, it's minutes that it took them to do the jigsaw puzzle. So you can say, on average, the boys took less time as they have a lower median, or a smaller median. There should be enough for a 1 to 2 mark question, but if they ask you to mention interquartile range, in the first one, it will be upper take away lower, so 33 take away 25, which would give you 8. And then in the second one, it will be about 27 take away 19, which is also 8. So you could say the spread of data is similar in both of them, but the medians are lower in the boys' case. Alright, moving on. So this time we're not given all the key information, we're just given a list of data that's been ordered. So we need to work out the lowest, highest, median, upper quartile and lower quartile. So we know the minimum value is the first one, which is 5, and the maximum is 44. So because this is a listed value, you're going to be using your n+1 formulas. So we'll start off with the median. So for the median, it's going to be at the n+1/2. Now we know there are 15 people, so 15 plus 1/2 will look for the 8th person. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 25. Similarly for the lower quartile, we're going to be doing n+1/4. So that's the 4th person, which is 14. And then the upper quartile is 3 lots of this. So we're looking for the 12th person. So 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 30. So now we have all of our key points. So let's draw the box plot. So lowest value is at 5. This time we're going 1 box for every value. And our highest value is at 44. Our lower quartile is now at 14. Our median is at 25. And our upper quartile is at 30. And then we just join everything up. Like so. Right, last part. So the second part of this question, the last thing we'll do, is as the box plot shows the distribution of times that people wait to be served at Green's Garden Centre. And in the first one we were looking at Rose Garden Centre. So it says compare the distribution. So we're going to compare the median and then the IQR. So the median here is 21, but the median in the first question was 25. So you could say here that on average so let's write it down, on average people wait longer at Roses as it has a higher median. Then if we're comparing the IQRs, Here we're going 35 to about 12. So the IQR in this one is about 23. And then in the first one, 30 take away 14, the IQR is about 16. So you could see here the spread of times at greens is more varied since it has a high QR. Greens is varied as it has a higher IQR. So the interquartile range lets you know how varied the data is, so which one has a more spread out times.